let's modify the behavior of this loop so that you can actually count backwards, but also do a bit more useful work. Now, remember this first section here, right, separated by semicolons, right? This will be our starting condition. So we want to start, let's say, I at 20, right? And this middle section here is the condition that must be satisfied in order for the loop to continue running, right? And we started start I as 20, right? How we want it to go downwards. Well, we would want it to decrease I, but then also we need to check and ensure, if we're going from 20 down to 0, the condition that must be satisfied is that I must be greater than or equal to 0, right? Rather than less than 10, right? Because when we're going down. So we can change this. Hey, as long as I is greater than or equal to 0, we don't want to increment it anymore. Because if I starts at 20, right, we'll get an infinite loop in this case because, well, I is 20 and I being 20 will always be greater than or equal to 0. So it will just keep on running over and over and over. Let me actually show you. All right. You see, keeps on going on and on and on. But no, we want to count downward. So we actually need to decrement I. So I minus minus, which is the same as I minus equal 1. So decrease I by 1 and set its new value. Right. So that value there, that's 1 less than 1. Then, well, the current value. Right. We can save. So let's save it, run it. See, we basically have I starting at, right? Well, it goes up. It starts at 20. You can't see it there, right? And it goes down to 0, right? Let's do a bit more useful work with it. We can say printf, right? From all this here, everything that's in between these two curly braces is actually governed by the for loop. So you can say I divided, right, by, we can say 5, right? Let's put a %d, right, for I, to swap with I. So we can say what the current value of I is divided by 5, right? We can say leaves a remainder. So we can use a modulo operator again, right? Of %d, right? Of course, don't forget your new line character because we're using printf, right? So I %5, right? So, well, if in the case of 20 divided by 5, you should get the remainder of 0. And then 19 divided by 5, you should get the remainder of 4. 18 divided by 5, you should get the remainder of 3, and so on and so forth, right? 5 going down to 0. 5 divided by 5, you get the remainder of 0, right? 4 divided by 5, you get the remainder of, 4 because it's 0 and 4 remainder, right? 3 divided by 5, 3, 2, 1. And of course, 0 divided by 5 leaves remainder 0. That's exactly what we expect, right? Let me actually take out this printf there, right? We could leave it in, but then it would kind of take some space, right? I see. As we predicted, 5 divided by 5 leaves remainder of 0, right? 4 divided by 5 leaves remainder of 4. 3 divided by 5 leaves a remainder of 3, and so on and so forth, right? So that works as expected.